Here we're going to draw the distance time graph of a moving body. Along the x-axis we take the time, so this is the x-axis, and here we will plot the time in second, and the distance we take along the y-axis, and there we will plot the distance in meters. Let's examine the table. At 0 seconds the distance is 0, so distance 0, so the point will be here. Here will be the point. Now for the second one, at 1 second the distance is 20. So at 1 second the distance is 20. The second point is going to be here. At 2 seconds the distance is 40. Now this is our 2 seconds here. The distance is 40. So here will be the point. Now the next is at 3 seconds it will be 60. So this is 3 seconds and this distance is 60. So the next point is going to be here at this. At 4 seconds it is 80. So this is 4 seconds here and this is 80 here. So at 4 seconds it will be 80. So here is the point. At 5 seconds it is 100. So this is 5 seconds along this line and 100 is along this. So the point will be here at the 5th second. And now when we join, this will be our distance time graph and it will be a straight line. Let's examine this graph a little bit. Let's see how we can calculate the speed from this graph. Now what is speed? We know speed equal to distance covered over time taken. Distance covered over time taken will be the speed. We'll take 2 points. Say at point 2 seconds, this 2 seconds, and we will take at 4 seconds. Let us see what is the speed of the object when it moves from point A to point B. So for point from A to B, to calculate speed, we need 2 things. We need to know distance covered and then we need to know the time taken. Now how to find the distance covered? At point A, if you see, what is the distance at point A? This is point A, and if you see, the distance is 40. And the time, if you notice, is 2 seconds. So at point A, which we are going to write here, the distance was, the position was 40 and the time was 2. Now at point B, what is the distance? The distance is now 80. This is the distance, 80. Here it was 40. And the time here is 4. Earlier it was 2. So when the body goes from A to B, from 40 it is moved to 80. So the distance will be 80 minus 40, and that the distance covered will be 40. It has moved, see, from 40 it is moved to 80. And the time taken for this was from 2 seconds, here is 2 seconds, to 4 seconds. So the time taken will be 4 minus 2, and that will be 2. So speed A to B is distance over time, and that is 40 meters over 2 seconds, and that will be 20 meter per second. That is the speed from A to B. Now again we will calculate the speed, say from point here, that is this point, we will call it as P, to this point here, we call it as Q. Let us see what is the speed in this case. So here we are calculating, we've done one. will calculate speed between P and Q. So we need two things. We need to know distance traveled and we need time taken. So from P to Q, what was the distance traveled? At P, the distance was 20. It was at 20 meters away. And at Q, see, 20 meters away. And at Q, it is 100 meters away. So the distance traveled will be 100 minus 20, and that is 80 meters. Now let's see the time. At P, the time was 1 second. And at Q, the time here is 5 seconds. So this is the time taken to travel from P to Q, and that is 5 minus 1, and that is 4. So speed here, speed is distance over time, which is 80 over 4, and again it is 20 meter per second. So this body is traveling at the same speed. You take any 2 points, it is covering 20 meters in every second. So every 1 second this body is covering 20 meters, which means it travels equal distance in equal time. Equal distance in equal time. Such motion is called uniform motion. So what is uniform motion? When a body travels equal distance in equal time, the body is said to be in uniform motion. Now let's mark the distance time graph of this body. At 0 it is 0, that means I'll mark here 0. At 1 second it is 5. At 1 second it is 5, that means it is at this point here. Then at 2 seconds is 20. 2 seconds it is at 20. Oh, we don't have 20 on this. We'll just go about plotting it again. So we said at 0 is 0, we marked here, and then we said at 1 it is 5. So at 1 it is 5. 5 will be somewhere here in between 0 and 10. Here will be 5. So it will be at this point here. Then at 2 it is 20. At 2 it is 20. So the point will be now here at this. Then we have at 3 it is 45. At 3, 45 will be between 40 and 50 here. This will be 45. So the point will be here now. At 4 it is 80. So this is 4 here. And this is 80 here. So at 4 will be 80, means at this point. And at 5 it is 125. However, I cannot take this on this graph. The 125 comes out a little bit somewhere here it will be. And 125 would be somewhere here like this at this point. So it would be here, about here. Okay. Now here we are going to join the graph. See, we're going to join it. And let's compare it with that earlier graph. See, it is not a straight line. It's like a curve. Here the body does not travel equal distances, equal intervals of time. Let us take like from 1 to 3 seconds. Now where is 1 to 3 seconds? This is at 1 second it is here. At this point P. And at 3 seconds it is at this point here. P and Q. So here at P, what is the distance? At P the distance is 10. At Q the distance is 45. So for PQ the distance traveled here is 45 minus 10, and that is 35. Now the time between P and Q, see for P this is the time, and for Q you see this is the time. So the time here between P and Q is 3 minus 1 and it is 2. So in 2 seconds it travels 35 meters. Let us take another 2 seconds now. So we'll take time, say we'll take this here, we'll write it as A, and the other one we'll take at 5 here, we'll write it as B. So we'll see between A and B, what is the distance it travels. So here for this distance will be 45 to 125. This was 125. So the distance traveled is 125 minus 45. And that works as 80. Now we'll see the time. For A, the time was this, 3. And for B, if you see, the time was 5. So this is the time from A to B. So the time here is 5 minus 3, and that is 2 seconds. Now look, let's compare. PQ, for PQ the time was 2 seconds, and for AB also the time was 2 seconds. But for PQ it traveled 35 meters. But between A and B it traveled 80 meters. Is it travel equal distance in equal intervals of time? No. In the first case, for 2 seconds it traveled 35. Next, equal time, 2 seconds, but it traveled 80 meters. Such motion is called non-uniform motion. And what is non-uniform motion? When a body travels unequal distance in equal intervals of time. So non-uniform motion is when a body travels unequal distances. This is important. Unequal distances in equal intervals of time. So let us a little summarize the things that we've learned. We've learned two things: uniform motion and non-uniform motion. In uniform motion, the graph of the body is a straight line. This is uniform motion. I will call this body A. This body A covers equal distance in equal intervals of time. Means every second it will cover an equal distance. This body is supposed to be in uniform motion, and if you see, the graph is a straight line. But let me take another example here of another body. See, like this. It's not a straight line. This is, say, body B. This body covers unequal distances in equal intervals of time. Means for every second it does not cover equal distance. In 1 second it may cover 10 meters. In another second it may cover 15 meters. In the third second it will cover 7 meters. So it covers unequal distances in equal intervals of time. And such motion is called non-uniform motion. It is not a straight line. It is a curve line. So by looking at the graph, you know if a body is of uniform motion or non-uniform motion. Again, I repeat, what is uniform motion? Equal distance in equal intervals of time. Non-uniform motion, unequal distance in equal intervals of time.